Welcome, sailor. This is the story of a rookie deckhand who joined a fishing boat to escape his old life, but found himself in command after the captain collapsed 200 miles from shore. With no experience and a storm approaching fast, he had to choose: take the helm or watch them all go down. The sea was merciless, time was running out, and somehow against everything he brought them home alive.
My name is Marcus Rivera, and for 8 years, I made my living as a tugboat captain working the deep water towing routes between the Gulf Coast ports and offshore drilling platforms. When people ask me about commercial maritime work, they usually think of crab fishing or cargo ships, the dangerous jobs that make headlines when things go wrong. Nobody thinks about tugboat operations as particularly risky. It's basically truck driving on water, my supervisor at Gulf Marine Services told me when I started in 2015. Point A to point B, nice and steady. The most dangerous part is the coffee in the galley. For 7 years that seemed true. I towed everything from construction barges to decommissioned oil rigs across the Gulf of Mexico, through weather that ranged from dead calm to moderate storms. The work was routine, well-paid, and relatively safe. Tugboats are built like floating tanks, designed to handle heavy loads and rough conditions. The crews are experienced professionals who've seen it all. That changed on March 15, 2023, when I took command of the tugboat Gulf Ranger for what should have been a routine tow from Morgan City, Louisiana, to a construction site 200 miles southeast in the deep Gulf. We were hauling a 300-foot equipment barge loaded with drilling machinery worth $12 million. The weather forecast called for light winds and calm seas, perfect conditions for a deep water tow. What happened over the next 4 days would teach me that there's no such thing as a routine operation when you're dealing with the ocean. When a single point of failure, one critical component that everyone trusted completely, gave way in the middle of the Gulf Stream, it set off a chain of events that turned a simple towing job into a fight for survival that tested everything I thought I knew about seamanship, leadership, and the weight of decisions that can save lives or destroy them. This is the story of how 4 experienced mariners and millions of dollars worth of equipment ended up at the mercy of one of the most powerful ocean currents in the world, with no engine power, no way to call for help, and a runaway barge that was drifting toward one of the busiest shipping lanes on the planet. It's about discovering that sometimes the greatest danger isn't the storm you can see coming, it's the failure you never imagined possible. I'd been working for Gulf Marine Services for 8 years when Captain Bill Morrison called me into his office in Morgan City on March 14, 2023. Morrison was a 30-year veteran of Gulf operations, the kind of man who'd seen every type of weather and cargo the region could throw at you. When he had a special job, he usually gave it to crews he trusted completely. "Marcus, I've got a tow for you. Priority client, good money, but it needs to be done right," he said, sliding a manila folder across his desk. "Chevron's moving some heavy drilling equipment to their new platform site. The Gulf Ranger leaves tomorrow morning." The job details were straightforward. Tow the equipment barge Pelican Bay from Morgan City to GPS coordinates in the deep Gulf, approximately 200 miles southeast. The barge was loaded with a drilling mud system, pipe handling equipment, and other machinery needed for the platform's next phase of construction. Total cargo value, $12 million. "Weather looks good for the next week," Morrison continued. "Light winds, seas 2 to 4 feet. Should be a milk run. 3 days out, maybe 2 days on location for the offload, then back home. Easy money." The Gulf Ranger was a perfect boat for the job. A 120-foot ocean-going tugboat built in 1998 specifically for deep-water operations. Twin 3,500 horsepower diesel engines, state-of-the-art navigation electronics, and accommodations for a crew of 6. She'd made hundreds of similar tows without incident, earning a reputation as one of the most reliable vessels in the Gulf Marine fleet. I met my crew at the dock that evening to go over the job details and conduct our pre-departure safety briefing. For a tow this size, we'd operate with a crew of 4. Myself as captain, plus an engineer, a deckhand, and a cook who also served as the boat's medic. Robert "Bobby" Tran was my engineer, a Vietnamese-American from New Orleans who'd been working marine engines for 15 years. Bobby was the kind of engineer every captain dreams of having. He could diagnose problems by sound, fix almost anything with spare parts and ingenuity, and he understood that keeping the engines running was what kept everyone alive out there. James Washington was our deckhand, a 45-year-old African-American from Mobile, Alabama, who'd been working tugboats since he was 18. James had hands like baseball mitts and an intuitive understanding of wire rope, winches, and the physics of moving heavy objects on a moving platform. When it came to deck operations, there wasn't anyone I trusted more. Maria Santos was our cook and medic. a 42-year-old former Navy corpsman from Houston who transitioned to civilian maritime work after retiring from the service. Maria kept us fed, patched up our minor injuries, and maintained the medical supplies that could mean the difference between life and death if someone got seriously hurt far from shore. Together, we'd worked as a team for 3 years, completing dozens of tows without serious incident. We knew each other's strengths, trusted each other's judgment, and had developed the kind of seamless cooperation that makes complex operations look easy. The Pelican Bay was a typical Gulf Coast construction barge, 300 feet long, 100 feet wide, with a flat deck designed to carry heavy industrial equipment. She was loaded with drilling machinery that had been precisely positioned and secured for the ocean voyage. The total weight of barge and cargo was approximately 8,000 tons, a substantial load, but well within the Gulf Ranger's capabilities. The tow setup was critical. A 2,000-foot length of 2¼ wire rope connected the tugboat to the barge, with the connection point on the barge reinforced with additional steel plating to handle the loads. The wire rope itself was rated for 400,000 pounds braking strength, far more than needed for this operation with multiple safety factors built in. This cable could tow 3 barges this size, James said as we inspected the gear before departure. Overkill, but that's how we like it. The tow bridle on the barge consisted of 2 heavy steel cables that distributed the load across multiple attachment points, preventing stress concentrations that could cause structural failure. Everything had been inspected, certified, and approved by marine surveyors. The setup was textbook perfect. We left Morgan City at 6 a.m. on March 15th under overcast skies with light southeast winds. The Gulf Ranger had no trouble getting the heavy barge moving, and within an hour we'd settled into our cruising speed of 6 knots, fast enough to maintain schedule, slow enough to keep stress on the tow gear to a minimum. The route took us southeast through the shallow waters of the Louisiana coast, then into the deeper waters of the Gulf where the continental shelf drops away into blue water thousands of feet deep. For the first 12 hours, everything went exactly according to plan. "Beautiful day for a tow," Maria commented as she served lunch in the galley. Through the windows, we could see the Pelican Bay following obediently behind us, riding steady in the light seas. The weather forecast continued to look good, high pressure dominating the region with no storms or significant wind expected for the rest of the week. Bobby's engines were running perfectly, maintaining power with the easy confidence of well-maintained machinery. James had settled into the routine of checking the tow gear every hour, monitoring the wire rope for any signs of wear or unusual stress. I spent most of my time in the wheelhouse, navigating around other vessel traffic and monitoring our progress toward the platform site. At 2 p.m., about 60 miles southeast of Morgan City, James came to the wheelhouse with news that made me pause. "Captain, I'm seeing some unusual wear on the wire rope where it passes through the towing block," he reported. "It's minor, but it wasn't there this morning. Wire rope wear is normal on long tows, but it usually develops gradually over days or weeks, not hours." I followed James aft to examine the cable where it passed over the massive steel roller that guided it from the boat to the barge. What I saw was concerning but not alarming. Several of the wire rope's outer strands were beginning to fray where they contacted the block. It was the kind of wear that typically develops over hundreds of miles of towing, not 60. "Could be a rough spot on the block that we missed during inspection," James suggested. "Or maybe this particular section of wire got damaged during the last tow and we didn't notice." I studied the wear pattern through binoculars. The fraying was concentrated in one area, suggesting a point of unusual stress or contact with a rough surface. "Keep monitoring it," I decided. "Document the wear with photos every hour. If it gets worse, we'll need to shorten up the tow and inspect the whole system." It was a reasonable precaution for what appeared to be a minor problem. Wire rope is incredibly strong, and even with some outer strand damage, the cable would retain most of its strength. We had spare wire aboard if needed, and the weather remained perfect for any repairs that might be necessary. Entering deep water by evening, we were in 3,000 feet of water, far from any land or shallow water refuge. The Louisiana coast was a distant smudge on the horizon behind us, and ahead lay nothing but open ocean stretching to the Yucatan Peninsula 400 miles away. We were entering the realm of the Gulf Stream, where the warm waters of the Caribbean flow northward through the Gulf of Mexico before being channeled between Florida and Cuba into the Atlantic. The Gulf Stream is one of the world's most powerful ocean currents, carrying 30 million cubic meters of water per second at speeds that can exceed 5 knots. For ships with their own power, it's a useful boost when traveling north or a manageable obstacle when traveling south. For a tugboat with a heavy tow, it represents a significant complicating factor that must be carefully managed. Currents running about 3 knots to the northeast, I announced to the crew after checking our GPS position against the chart. We'll need to adjust our heading to compensate, but it shouldn't affect our arrival time significantly. What I didn't mention was my growing concern about the wire rope wear. James' hourly inspections showed that the fraying was continuing to develop, though slowly. By 10 p.m., approximately 10% of the rope's outer strands showed damage in the area of the towing block. Still within acceptable limits, James reported, but if this keeps up, we might need to think about changing out the wire. Changing the tow wire in deep water is a complex operation that requires calm conditions and several hours of precise deck work. With the current weather, it would be manageable if necessary, but it would delay our arrival and complicate the job significantly. We'll reassess in the morning, I decided. For now, continue monitoring. That night, as I stood watch in the wheelhouse while my crew slept, I felt the satisfaction that comes from a job going according to plan. The Gulf Ranger was running smoothly, the barge was tracking perfectly, and we were making good time toward our destination. The sea was nearly flat calm, with just enough swell to keep the boat moving in a gentle, rhythmic motion. At 3 a.m., I called Bobby to relieve me for the midnight to 6 watch. "Any issues?" he asked as he settled into the captain's chair. "Wire rope wear is developing faster than I'd like, but James says it's still within limits. Otherwise, everything's perfect. Course 140 degrees, speed 6 knots, ETA platform sight tomorrow afternoon. Weather still looking good? High pressure holding, light winds, calm seas for the next 48 hours minimum. Should be a textbook tow." As I headed to my bunk, I remember feeling grateful for the routine nature of the job. After 8 years of tugboat operations, I'd learned to appreciate the boring runs. The tows where nothing went wrong, where professional competence and good equipment combined to move cargo safely from point A to point B. I had no idea that in 6 hours, everything I thought I knew about the limits of marine equipment and the predictability of routine operations would be challenged in ways I'd never imagined possible. I woke up at 7 a.m. to the familiar motion of the Gulf Ranger working through a gentle swell. Bobby was still on watch, and through my cabin porthole, I could see perfect conditions. Light winds, clear skies, and seas that looked more like a lake than the Gulf of Mexico. We were approximately 150 miles from shore, making steady progress toward the platform site. In the galley, Maria had coffee ready and was preparing breakfast for the crew. "Beautiful morning," she said as I poured a cup. "Bobby says we're making good time. Should reach the platform site by 4 p.m. if this weather holds." James was already on deck, conducting his morning inspection of the tow gear. Through the galley windows, I could see him working his way aft along the wire rope, examining every section with the methodical care of a man who understood that his life, and everyone else's, depended on that steel cable holding. When he came in for breakfast, his expression was more serious than I'd expected. "Captain, we need to talk about this wire rope situation," he said, setting down his inspection log. "The wear pattern is accelerating. What started as minor fraying yesterday is now showing significant strand damage over about a 6-foot section." I studied his documentation, photos taken every hour showing the progressive deterioration of the wire rope's outer strands. What had been a few broken wires at 2 p.m. yesterday was now extensive damage affecting nearly 20% of the cable's cross-sectional area in the worst spot. "Any idea what's causing it?" I asked. "Best guess is a burr or rough spot on the towing block that's grinding the wire every time it moves. The motion is subtle, you can't see it unless you watch closely, but over hundreds of cycles, it's acting like a file." Wire rope failure is every tugboat captain's nightmare. The forces involved in deep water towing are enormous, and when a tow wire fails, the results can be catastrophic. The barge becomes an uncontrolled drifting object. The tugboat loses its load and can be damaged by the whipping cable, and in extreme cases, the snapback energy can kill crew members on deck. "Options?" I asked. "We can shorten up the tow to 1,000 feet and try to change out the wire, but that's a 6-hour operation in perfect conditions. Or we can continue monitoring and hope the damage stabilizes. The inner core of the wire is still intact. This cable should still have 80% of its rated strength. 80% of 400,000 pounds was still 320,000 pounds. More than enough for our 8,000-ton load under normal conditions. But normal in the maritime world includes a safety factor for unexpected stresses, sudden loads, and equipment failures." I called Bobby to the galley for a crew meeting. As engineer, his input on mechanical systems was crucial for making the right decision. "The engines are running perfectly," he reported. "No issues with power, and the weather forecast is still calling for calm conditions through tomorrow. If we're going to change the wire, now would be the time to do it. What's the risk if we continue with the damaged wire? I asked James. Hard to quantify exactly. In these conditions with this load, the wire should hold indefinitely even with the damage we're seeing. But if we hit unexpected weather, if we need to maneuver suddenly, if the barge takes a bad sea. He paused. The safety margin is getting thin. I studied the charts, considering our options. We were 150 miles from shore, 50 miles from the platform site. Changing the wire would delay our arrival by at least 8 hours and expose the crew to the risks inherent in heavy deck work. Continuing with the damaged wire meant accepting a reduced safety margin but maintaining our schedule. We continue monitoring, I decided. But we reduce speed to 4 knots to minimize stress on the wire, and James, I want inspections every 30 minutes instead of every hour. Any further deterioration and we stop immediately to change the wire. It was a calculated risk based on experience and professional judgment. The wire rope still had substantial strength, the weather was perfect, and we were less than 12 hours from completing the tow. Under those conditions, proceeding with increased monitoring seemed reasonable. I would question that decision for the rest of my life. By noon, we had entered the main flow of the Gulf Stream. The change was immediately apparent. The water turned from the green-gray of coastal areas to a deep blue that seemed to glow with its own light. The surface temperature rose 10 degrees, and I could feel the current's power in the way it affected our navigation. Currents running 2 knots to the northeast, I announced after checking our GPS position. We'll need to adjust course by 15 degrees to maintain our track to the platform site. The Gulf Stream is a river in the ocean, carrying warm water from the Caribbean northward at tremendous velocity. For our purposes, it meant constantly adjusting our heading to compensate for being pushed off course. More significantly, it meant that any emergency would occur in one of the most remote areas of the Gulf of Mexico, far from shore and in waters where the current could carry disabled vessels hundreds of miles from their last known position. How's the wire looking, James? I asked during his 12:30 inspection. Stable for now. The damage doesn't seem to be progressing as fast as it was this morning. Maybe we caught a break. For the next 3 hours, that assessment seemed accurate. The wire rope wear had stabilized at roughly 25% strand damage in the worst area. Significant, but not immediately threatening. Our reduced speed was keeping stress on the tow gear to a minimum, and the perfect weather was holding. At 3:45 p.m., just 15 miles from the platform site, James made the radio call that changed everything. Captain to the wheelhouse immediately. Emergency on deck. I reached the stern deck in less than 30 seconds to find James staring at something that shouldn't have been possible. The massive steel towing block, a piece of equipment designed to handle millions of pounds of force, had cracked along its mounting bracket. It just happened, James said, his voice tight with controlled urgency. I was doing my regular inspection when I heard a metallic popping sound. Look at this. The crack was clearly visible, running along the weld where the towing block was attached to the boat's main towing post. As I watched, the crack seemed to grow slightly, opening under the stress of the tow wire passing over the block. How bad is it? I asked, though I could already see the answer. Bad. If that mounting bracket fails completely, the towing block will tear loose. When it does, the wire rope will either snap from the sudden shock load or wrap around something and jam. Either way, we lose the tow. A failed tow wire 200 miles from shore is one of the worst emergencies a tugboat can face. The barge would become a drifting hazard, pushed by wind and current toward shipping lanes or shallow water. The tugboat would lose its ability to control the situation and might be damaged by the whipping cable when it let go. Can we reinforce the mounting bracket? I asked. Maybe, but it would require shutting down the tow completely and doing major welding work. And Captain. James pointed to the wire rope where it passed over the damaged block. The crack is causing the block to bind. It's making the wire rope wear even worse. As if to emphasize his point, I could see several more wire strands part as we watched, the steel fibers snapping under the increased friction caused by the damaged block. I keyed the radio to contact the platform site. Chevron Platform Charlie, this is Tug Gulf Ranger with your equipment barge. We have a developing emergency with our tow gear. Request immediate assistance. The response came back immediately. Gulf Ranger, this is Platform Charlie. What is the nature of your emergency? We have structural failure developing in our towing block and concurrent wire rope damage. We're 15 miles from your position but may lose the tow at any time. Request you stand by for emergency assistance and notify the Coast Guard of our situation. Roger, Gulf Ranger. We're alerting our emergency response team and notifying Coast Guard New Orleans. What assistance do you need? That was the question I was hoping to avoid. In theory, the platform had work boats that could assist with the tow if our equipment failed completely. In practice, transferring a 300-foot barge from one vessel to another in open water was extremely dangerous and had never been attempted with a load this size. Stand by, Platform Charlie. We're assessing our options. I called the crew together in the wheelhouse for an emergency meeting. Through the windows, we could see the platform's derricks on the horizon, tantalizingly close, but still too far away to reach if our tow gear failed. Here's our situation, I began. The towing block is failing, the wire rope is deteriorating rapidly, and we're running out of time. We have 3 options and none of them are good. Option 1. We continue the tow at reduced speed and pray the equipment holds for another 2 hours. If it works, we complete the job. If it fails, we lose the barge in 3,000 feet of water. Option 2. We stop immediately and attempt to reinforce the towing block. That's a minimum 6-hour job with no guarantee of success, and we'd be dead in the water in the Gulf Stream current. Option 3. We deliberately release the tow now while we still have some control, and let the platform's work boats attempt to secure the barge. That's never been tried with a load this size, and the odds of success are poor. Maria spoke first. What happens to the barge if we lose it completely? It becomes a drifting hazard worth $12 million, pushed by the current toward the shipping lanes between New Orleans and Houston. Eventually, it would either run aground on the Texas coast or sink in deep water. Bobby was studying the engine gauges. The power plant is solid. If we need to maneuver quickly or hold position, the engines can handle it. The real question, James said quietly, is how much time do we have? That crack in the towing block is getting worse every minute. And Captain. He paused, looking out at the barge. We need to consider what happens to anyone on deck when that wire rope lets go. He was talking about the snapback, the potentially lethal whip of steel cable that occurs when a wire rope fails under load. Men had been killed by failed tow wires, and the energy stored in 2,000 feet of cable under tension was enormous. At 4:15 p.m., the decision was made for us. James, who had been monitoring the towing block continuously, called out the words every tugboat captain dreads. The block is failing. The mounting bracket is tearing loose. I could see it happening. The massive steel assembly that controlled our connection to the barge was literally tearing itself apart under forces it had been designed to handle easily. The crack had propagated along the entire weld, and the block was hanging at an angle that put impossible stress on the wire rope. All hands clear the stern deck. I ordered. James, get inside now. Captain, the wire rope. He started. Inside. That's an order. 10 seconds later, the inevitable happened. The towing block tore completely free from its mounting bracket with a sound like a gunshot. The 2¼ inch wire rope, suddenly released from its guide path, whipped across the stern deck with the fury of a steel serpent, gouging chunks out of the steel plating before disappearing over the side. In the space of 5 seconds, we had gone from a routine tow 15 miles from completion to a maritime emergency 200 miles from shore. The Pelican Bay, with its $12 million of cargo, was now a free-drifting barge in the Gulf Stream, and we had no way to control it. The real crisis was just beginning. Without the resistance of the tow wire, the Gulf Ranger immediately began to gain speed while the Pelican Bay started to slow. More significantly, the Gulf Stream current began to affect both vessels differently. The tugboat, with its deep draft and powerful engines, could maintain position against the current. The barge, with its shallow draft and large surface area, became a captive of wind and current. Platform Charlie, this is Gulf Ranger, I called on the radio. Our tow gear has failed completely. The barge is now drifting free approximately 13 miles from your position. Roger, Gulf Ranger. We're launching our emergency response boat and notifying all shipping in the area. What is your status? We're undamaged but unable to reconnect to the barge without major repairs to our tow gear. The barge is drifting northeast with the current at approximately 3 knots. What I didn't say, because it was too terrifying to voice, was that the Pelican Bay was now heading directly toward one of the busiest shipping lanes in the Gulf of Mexico. If we couldn't somehow regain control of the situation, a 300-foot barge loaded with industrial equipment would become a collision hazard for every vessel transiting between New Orleans and the Yucatan. The clock was ticking and our options were running out fast. Within 30 minutes of losing the tow wire, the Pelican Bay had drifted almost 2 miles from our position. From the Gulf Ranger's wheelhouse, I could see the barge as a distant speck on the horizon. moving steadily northeast with the Gulf Stream current at nearly 4 knots. "She's picking up speed," James observed, tracking the barge through binoculars. "Wind and current are both pushing her the same direction now." The physics of the situation were working against us. The Gulf Ranger, with her deep draft and powerful engines, could maintain position or move independently of the current. The Pelican Bay, essentially a floating platform with no propulsion, was completely at the mercy of natural forces that were pushing her toward disaster. I spread the navigation charts across the wheelhouse table and began calculating drift patterns. The results were sobering. At current speed and direction, she'll enter the main shipping channel between New Orleans and Mexico in approximately 18 hours, I announced to the crew. After that, she becomes a collision hazard for every vessel on one of the busiest shipping routes in the Gulf. "What about the Coast Guard?" Maria asked. "Can't they stop her?" "The nearest Coast Guard vessel capable of handling something this size is probably 8 hours away minimum. And even then, connecting a tow line to a drifting barge in open water." I didn't finish the sentence. We all knew it was nearly impossible. The workboat from Platform Charlie reached us just as the sun began to set, a 65-foot crew boat designed for personnel transport and light cargo work. Captain Pete Rodriguez was a 20-year veteran of Gulf operations, but as he maneuvered alongside the Gulf Ranger, I could see the concern in his face. "Marcus, I've seen some situations out here, but I've never dealt with anything like this," he said as we discussed options over the radio. "My boat can handle maybe 500 tons of tow in perfect conditions. That barge is 8,000 tons and drifting at 4 knots. Can you get a line aboard her?" I asked. "We can try, but even if we manage it, I don't have the power to stop her drift. Best I could do is maybe slow her down or change her direction slightly." It was a start, but not a solution. We needed a way to either stop the barge completely or guide her away from the shipping lanes until a proper salvage vessel could reach the scene. By 8 p.m., Gulf Marine Services had contracted Titan Salvage, one of the premier marine salvage companies in the region. Their nearest suitable vessel was the Sea Guardian, a 200-foot ocean-going tug with the power to handle jobs like this. But she was currently in Port Arthur, Texas, and wouldn't reach our position for at least 12 hours. "Can you maintain visual contact with the barge until we arrive?" the salvage coordinator asked over the satellite phone. "Affirmative," I replied. "But we need to consider what happens if weather conditions deteriorate. The forecast is still calling for calm seas, but this is the Gulf of Mexico in March. Things can change fast." "Understood." We're also coordinating with the Coast Guard to establish a safety zone around the barge and divert shipping traffic. "But Captain Rivera, I need you to understand something. If that barge enters the shipping channel before we can secure it, we may have to consider other options." Other options. In salvage terminology, that meant potentially sinking the barge deliberately to remove it as a navigation hazard. $12 million of equipment sent to the bottom rather than risk a collision that could kill dozens of people and cause an environmental disaster. As darkness fell, we began the long night of shadowing the drifting barge. The Gulf Ranger had powerful searchlights that could illuminate the Pelican Bay from a distance, and we equipped her with emergency strobes to make her visible to other vessels. But tracking a dark object on a dark ocean while maintaining a safe distance required constant vigilance. "She's still making 3.8 knots to the northeast," Bobby reported during his midnight watch. "If this keeps up, she'll be in the shipping channel by 2 p.m. tomorrow." I was studying weather data in the wheelhouse, looking for any change that might alter the barge's drift pattern. Currents actually accelerating as we move further into the Gulf Stream. She could be making 4.5 knots by morning. The irony wasn't lost on me. We were watching millions of dollars worth of equipment drift toward disaster, while shadowing it in a tugboat perfectly capable of controlling the situation. If only we had a way to reconnect. The failed towing block was like a severed artery. Without it, we were helpless to stop the bleeding. At dawn on March 17th, Captain Rodriguez made his attempt to get a line aboard the Pelican Bay. We watched from a mile away as his crew boat approached the drifting barge, fighting against the same current that was pushing her northeast. The plan was simple in theory: get close enough to the barge's stern to shoot a line aboard with a line gun, then use that messenger line to pull across a heavier rope that could serve as a temporary tow line. In practice, it required precise boat handling in close quarters with a massive drifting object. "He's making his approach," James called out, tracking the operation through binoculars. "Coming up on her port quarter." For 20 minutes, we watched Rodriguez battle the current and wind to maintain position near the barge. His crew managed to get a messenger line aboard, then began the delicate process of pulling across heavier rope. But as soon as they applied tension to the line, the physics of the situation became clear. "The line's not holding," Maria observed. "The barge is just pulling the workboat along with her." Rodriguez tried for another hour, attempting to use his boat's power to slow the barge's drift or change her direction. But the forces involved were simply too great. His 2,000 horsepower engines were no match for the Gulf Stream's tremendous power acting on 8,000 tons of barge and cargo. "Gulf Ranger, this is Platform Charlie workboat," Rodriguez called over the radio. "I can't do it. The current's too strong and I don't have the power to make a difference. I'm breaking off before I damage my boat or lose someone overboard." By 10 a.m., we began encountering the first vessels using the shipping channel that the Pelican Bay was approaching. A container ship bound for New Orleans passed 3 miles to our east, her captain acknowledging our radio warnings about the drifting barge. "The Coast Guard has issued a notice to mariners," I announced to my crew after receiving an update from the Rescue Coordination Center. "All shipping has been advised of the hazard, but they can't close the entire channel. Too much commercial traffic depends on it." The mathematics were becoming more urgent. The barge was now less than 50 miles from the main shipping lane, making 2 knots in the strengthening current. At that rate, she would enter the channel in less than 12 hours, several hours before the salvage tug was due to arrive. "What happens if a ship hits her?" Bobby asked. "Depends on the ship and the impact angle," I replied. "Best case, they damage the barge and maybe punch a hole in the ship's bow. Worst case." I didn't finish. Everyone on the bridge understood the implications. A high-speed collision between a loaded tanker and a stationary barge could cause explosions, massive oil spills, and loss of life. At 2 p.m., the first sign of changing weather appeared on the radar, a line of thunderstorms building to the southwest. The morning's weather forecast had called for continued calm conditions, but the Gulf of Mexico is notorious for developing localized weather systems that can't be predicted far in advance. "Those storms are moving northeast at about 25 knots, I observed, studying the radar display. "If they maintain course and speed, they'll reach us in about 4 hours. Thunderstorms in the Gulf can generate winds exceeding 60 knots and seas of 15 feet or more in a matter of minutes. For a drifting barge, storm conditions would make any rescue attempt exponentially more dangerous. Worse, the wind could change the barge's drift pattern, potentially pushing her directly into the path of oncoming vessels rather than parallel to the shipping lane. We need to inform the salvage tug about this weather development," I decided. "If those storms hit before they arrive, this whole situation becomes much more complicated." The Sea Guardian had been making maximum speed from Port Arthur since receiving the emergency call, her twin 4,000 horsepower engines pushing her through the Gulf waters at 12 knots. Captain Sarah Mitchell, the salvage master, had been coordinating with us by satellite phone throughout the day. "We're still 8 hours out," she reported at 3 p.m., "but I'm seeing the same weather data you are. If those storms reach the barge before we do, we'll have to wait them out. Can't attempt a connection in storm conditions with that much equipment at stake." 8 hours would put the Sea Guardian on scene at 11 p.m., well after the barge had entered the shipping channel. And if the storms forced a delay, the situation could become completely unmanageable. "Captain Mitchell, what's your assessment if we can't secure the barge before she reaches the shipping lane?" I asked. There was a long pause before she answered. "Captain Rivera, at that point we're looking at a potential decision to sink her deliberately. Better to put $12 million on the bottom than risk a collision that could kill people and cause an environmental disaster." The weight of that possibility settled over our crew like a physical presence. We were watching the slow-motion destruction of millions of dollars worth of equipment, and there was nothing we could do to stop it. At 5:45 p.m., the first line of thunderstorms reached us. The change was dramatic and immediate. Winds that had been light and variable suddenly gusted to 45 knots, and the seas built from 2 feet to 8 feet in less than 30 minutes. "Pelican Bay is starting to respond to the wind," James reported, fighting to keep his binoculars steady in the rough conditions. "She's being pushed more to the east now, but also moving faster." The combination of wind and current was accelerating the barge's drift toward the shipping channel while also making her a more difficult target for any rescue attempt. The flat deck that had made her stable in calm conditions now acted like a sail, catching the wind and adding to the forces pushing her toward disaster. "How's she riding in these seas?" I asked, concerned about the cargo securing. "Hard to tell from this distance, but she's starting to pitch and roll more. If any of that drilling equipment breaks loose." A cargo shift on a barge can be catastrophic, changing her stability characteristics and potentially causing her to capsize. The equipment aboard the Pelican Bay had been secured for ocean transport, but no securing system is designed to handle the combination of storm conditions and uncontrolled drifting. As the storm intensified, the Coast Guard established a formal emergency coordination center to manage the developing crisis. Coast Guard Sector New Orleans took command of the response, coordinating between the salvage tug, merchant vessels in the area, and emergency response teams. All vessels, this is Coast Guard New Orleans broadcasting a maritime safety message, came the announcement over Channel 16. Navigation hazard, drifting barge, position 28 degrees 15 minutes north, 89 degrees 42 minutes west, drifting northeast at 5 knots. All vessels maintain a minimum 2-mile clearance. 2 miles sounded like a lot, but for a ship traveling at 20 knots, it represented less than 6 minutes of reaction time. And in storm conditions with reduced visibility and rough seas, even experienced mariners could be caught off guard by a dark object on a dark ocean. At 8:30 p.m. we had our first real scare. A bulk carrier bound for Houston, the Atlantic Voyager, reported radar contact with what appeared to be the drifting barge just 4 miles ahead of her position. Atlantic Voyager, this is Coast Guard New Orleans, came the immediate response. Confirm your radar contact. Bearing and distance to target. Coast Guard, the target bears 0.45 degrees relative, distance 3.8 miles. We're altering course to starboard to maintain clearance, but visibility is reduced in these squalls. From our position shadowing the barge, we could see the Atlantic Voyager's lights approaching from the southwest. The 600-foot bulk carrier was loaded with grain, riding deep in the water and requiring significant distance to maneuver. Gulf Ranger, can you illuminate the barge for the merchant vessel? The Coast Guard requested. We immediately trained our searchlights on the Pelican Bay, creating a cone of white light that made her clearly visible against the dark water. The Atlantic Voyager altered course by 20 degrees, passing the barge with a half-mile to spare. Coast Guard, this is Atlantic Voyager. Target is clearly visible now. Passing clear to starboard. But I need to tell you, if this was daylight with good visibility, that would have been a very close call. In these conditions at night, other vessels might not be so lucky. By 10 p.m., the Pelican Bay had entered the outer edge of the shipping channel. The salvage tug was still an hour away, and the storm was showing no signs of abating. Winds were gusting to 55 knots, seas had built to 12 feet, and visibility was reduced to less than 2 miles in the frequent squalls. Captain Mitchell from the Sea Guardian called with the update we'd been dreading. The weather conditions are too severe for a safe approach to the barge. We're going to have to stand off until this system passes. How long? I asked. Weather Service says the storm should move through by dawn. But Captain Rivera, we need to discuss the elephant in the room. If that barge stays in the shipping channel overnight in these conditions with this much traffic. She didn't need to finish. We all understood the mathematics of disaster. Every hour the barge remained in the shipping lane increased the odds of a catastrophic collision. And with the weather preventing any rescue attempt, we were powerless to change the equation. Coast Guard is considering ordering all shipping to stop and anchor until the barge can be secured, Captain Mitchell continued. But that would affect hundreds of vessels and millions of dollars in commerce. They're not going to make that call lightly. At 11:15 p.m., the decision point arrived in the form of the tanker Gulf Star, a 900-foot vessel carrying crude oil from Mexico to refineries in Texas. Her captain, Jorge Mendoza, was facing the same impossible choice that maritime officers have confronted for centuries: proceed through a known hazard or stop and wait for conditions to improve. Coast Guard, this is motor tanker Gulf Star, came the call over Channel 16. We're tracking the reported navigation hazard on radar, but we have a cargo of crude oil that needs to reach port by 0600 tomorrow or we face significant penalty costs. Request permission to proceed with extreme caution. The response from the Coast Guard was immediate and firm. Motor tanker Gulf Star, negative. You are directed to heave to and maintain position until the navigation hazard is secured. This is not a request. Coast Guard, understood. But I need you to know that we're not the only vessel affected. There are at least 6 ships stacked up behind us, all with time-sensitive cargoes. The economic impact of stopping Gulf shipping is measured in millions of dollars per hour. It was the classic conflict between safety and commerce that defines modern maritime operations. The Coast Guard's primary responsibility was preventing loss of life, but the economic implications of stopping one of America's busiest shipping channels were staggering. As midnight approached, Captain Mitchell called with a proposal that was desperate enough to work. Captain Rivera, I've been studying the situation and I think there might be another option. Instead of trying to secure the barge directly, what if we use your boat and mine to herd her away from the shipping channel? Herding a barge involves using tugboats to push and guide a drifting object without actually connecting to it. It's a delicate operation that requires precise boat handling and coordination between vessels, but it can be effective for changing a drift pattern without the time and risk involved in making a tow connection. The idea is to use our combined power to push the barge further east, away from the main shipping lane and into deeper water where she's not a navigation hazard, Mitchell explained. It's not perfect, but it might buy us time to wait for better weather conditions. It was risky, maneuvering 120-foot tugboats close to a drifting 300-foot barge in storm conditions violated every principle of safe seamanship. But with merchant vessels backing up behind the Gulf Star and the economic implications mounting by the hour, desperate measures were starting to look reasonable. "What do you need from us?" I asked. "Coordinate with me on the approach. We'll use our boats like bulldozers, pushing against the barge's sides to change her heading. If we can get her moving more to the east and less to the north, we move her away from the shipping lane." At 1 a.m. on March 18th, under the worst possible conditions, we began the most dangerous boat handling operation of my career. The Sea Guardian approached the Pelican Bay from the southwest while we closed from the west, both boats using their engines and hull strength to physically push the drifting barge. "Easy on the power," Captain Mitchell advised over the radio. "Too much force and we could damage our hulls or cause the barge to develop an unpredictable motion." For 2 hours we played a deadly game of maritime bumper cars, using our tugboats to nudge the massive barge away from the shipping channel. The operation required absolute precision. Too little force and the barge would continue her drift toward disaster. Too much force and we risked damaging our own vessels or causing the barge to become unstable. "She's responding," James called out during one of our pushing maneuvers. "Heading is changing to the east." By 3 a.m., we had managed to alter the barge's drift pattern by approximately 15 degrees. Instead of heading directly into the heart of the shipping channel, she was now angling toward the channel's eastern edge, still a hazard but a more manageable one. "Coast Guard, this is salvage tug Sea Guardian," Captain Mitchell reported. "We've successfully altered the barge's drift pattern. She's now heading 070 degrees at 4.2 knots. Estimated time to clear the main shipping lane is 0800 hours." As the sun rose on March 18th, the storm system that had complicated everything finally began to move inland. Winds dropped to 20 knots, seas diminished to 6 feet, and visibility improved dramatically. For the first time in 12 hours, we could clearly see our situation. The Pelican Bay was now 15 miles east of the main shipping channel, still drifting northeast but no longer an immediate collision hazard. The herding operation had worked, barely, but the barge was still uncontrolled and still loaded with millions of dollars worth of equipment. "Weather window is opening up," Captain Mitchell announced. "I'm going to attempt to get a tow line aboard her while conditions are still workable." The next 2 hours would determine whether this would end as a successful salvage operation or a $12 million insurance claim on the bottom of the Gulf of Mexico. Dawn on March 18th brought the kind of weather that makes Gulf operations look easy: light winds, moderate seas, and unlimited visibility under clearing skies. After the chaos of the previous night's storm, the improvement felt almost miraculous. But the weather was only part of our problem. The Pelican Bay had been drifting uncontrolled for nearly 16 hours, pushed by wind and current across 60 miles of open ocean. The barge that had started as a routine cargo delivery was now a 300-foot hazard worth $12 million, still moving northeast at 3.8 knots in the strengthening Gulf Stream. "She's picked up some motion in the storm," Captain Mitchell observed from the bridge of the Sea Guardian as we maneuvered closer to the drifting barge. "Rolling about 15 degrees, pitching maybe 8 degrees. Not terrible, but it's going to complicate the connection." From my position aboard the Gulf Ranger, I could see what she meant. The Pelican Bay, designed to be towed in calm conditions, was now moving with the unpredictable motion of a free-floating object. Every wave caused her to pitch, roll, and yaw in ways that would make getting a line aboard dangerous for the salvage crew. Captain Sarah Mitchell had 30 years of experience in marine salvage, including operations in some of the world's most challenging conditions. Her plan for securing the Pelican Bay was methodical and professional, but it required perfect execution under less than perfect circumstances. "We're going to approach from the stern quarter and use a line gun to get a messenger line aboard," she explained over the radio. "Once we have that connection, we'll pull across a heavier hawser that can handle the loads. The critical part is maintaining position during the connection. If we get too close and the barge surges toward us, we could have a collision. The physics of the operation were unforgiving. The Sea Guardian would need to match the barge's speed and course while maneuvering close enough for the line gun to be effective, probably within 100 feet. At that distance, any miscalculation could result in a collision between a 200-foot tugboat and a 300-foot barge, both moving at nearly 4 knots. Gulf Ranger, I need you to maintain position about a quarter-mile away and provide backup communications, Captain Mitchell continued. If something goes wrong during our approach, you'll be our link to the Coast Guard. At 8 a.m., the Sea Guardian began her approach to the Pelican Bay's stern. I watched through binoculars as Captain Mitchell demonstrated the precise boat handling that made her one of the Gulf's most respected salvage masters. The tugboat closed the distance slowly, matching the barge's course and speed while accounting for the wind and current that were affecting both vessels differently. At 200 feet, the Sea Guardian's crew prepared the line gun, a pneumatic device that could shoot a weighted line across the gap between vessels. Sea Guardian, this is Gulf Ranger, I called. You're looking good from our position. Barge motion appears stable. Roger. Beginning our connection attempt now. The first shot from the line gun arced perfectly across the gap, landing on the barge's stern deck where the salvage crew could secure it. For a moment, it looked like the operation might be completed quickly and professionally. Then the Gulf Stream intervened. As the Sea Guardian's crew began pulling the heavier hawser across on the messenger line, the current caught the barge's broadside and pushed her away from the tugboat. The angle between the vessels changed rapidly, putting impossible stress on the thin messenger line. Lines parted, came the call from the Sea Guardian. We're going around for another approach. For the next 2 hours, Captain Mitchell and her crew attempted to establish a tow connection with the drifting barge. Each attempt followed the same pattern: a skillful approach, a successful line gun shot, then failure as the current and the barge's unpredictable motion broke the connection before a proper hawser could be rigged. This is harder than I expected, Captain Mitchell admitted during a break between attempts. The current differential between the tug and the barge is making it almost impossible to maintain the right geometry for long enough to get a heavy line across. I was watching the operation with growing respect for the difficulty of what we were attempting. In calm water with cooperative vessels, rigging a tow line is routine. But connecting to a free-drifting object in the Gulf Stream required a combination of skill, timing, and luck that was proving elusive. Any other options? I asked. We could try a different approach angle or wait for the current to weaken, but neither of those guarantees success. Or, she paused, we could try something that's never been done with a barge this size. What Captain Mitchell proposed violated every principle of conventional salvage operations, but it might be our only chance of success. Instead of trying to connect to the barge while both vessels were underway, she wanted to use the Sea Guardian's superior power to get ahead of the Pelican Bay, then allow the drifting barge to overtake the tugboat while the salvage crew made the connection. It's called a backing and filling maneuver, she explained. We position ourselves directly in front of the barge's drift path, then use our engines to control our relative position while she approaches. When she's close enough, we shoot the line back to her instead of forward. The maneuver required incredible precision. Too far ahead, and the barge would change course before reaching the tugboat. Too close, and the 8,000-ton barge would run down the much smaller tugboat with potentially catastrophic results. The window for success is maybe 30 seconds, Captain Mitchell continued. And if we screw it up, we could lose both vessels. At 11 a.m., with merchant shipping still backed up and waiting for the channel to clear, Captain Mitchell attempted the most dangerous salvage maneuver of her career. The Sea Guardian accelerated ahead of the drifting barge, then reduced power and began the delicate process of positioning herself in the Pelican Bay's path. Gulf Ranger, I need constant updates on the barge's position and motion, Captain Mitchell called. Any change in her heading or speed, let me know immediately. From our position a quarter-mile away, I had the best view of the entire operation. Through binoculars, I could see the Sea Guardian maneuvering directly in front of the massive drifting barge, her engines working to maintain precise position as 8,000 tons of steel and cargo approached at nearly 4 knots. Barge is 400 yards from your position, maintaining course and speed, I reported. Roger. Beginning backing maneuver now. Captain Mitchell began using her engines in reverse, slowing the tugboat's forward motion while allowing the barge to close the distance. The timing had to be perfect. Too much reverse power and the tugboat would move away from the barge. Too little and the barge would overtake them before the connection could be made. 300 yards, I called. 200 yards. 100 yards. You're in the envelope now. At 75 yards distance, with the massive barge bearing down on the tugboat like a slow-motion avalanche, Captain Mitchell's crew fired the line gun. The weighted line arced across the narrowing gap, trailing its messenger rope in a perfect trajectory toward the barge's bow. "Lines aboard!" came the shout from the barge's deck, where one of the salvage crew had managed to reach the messenger line. But now came the most dangerous part of the operation. With less than 50 yards between a 200-foot tugboat and a 300-foot barge, both moving at several knots, the crew had to quickly pull across a hawser heavy enough to handle the towing loads, all while avoiding a collision that could sink both vessels. "Hawsers going across now," Captain Mitchell reported, her voice tight with concentration. "But we're running out of room. If this doesn't work in the next 30 seconds, I'm going to have to abort." Through binoculars, I could see the organized chaos on both vessels as crews worked frantically to complete the connection. The heavy towing hawser was halfway across the gap, but the barge was still closing on the tugboat with the inexorable force of 8,000 tons in motion. 25 yards and closing," I called out, watching the gap narrow to a distance that made collision seem inevitable. At exactly the moment when collision seemed certain, the connection was completed. The salvage crew aboard the Pelican Bay secured the hawser to the barge's towing bits, and Captain Mitchell applied power to take the strain. The effect was immediate and dramatic. The tugboat's engines, suddenly loaded with the full weight of the drifting barge, slowed both vessels and began the process of bringing the situation under control. But the margin for error had been measured in seconds and feet. "Sea Guardian to Gulf Ranger," came the call over the radio. "We have a successful connection. Barge is now under tow." "But Captain Rivera." There was a pause. That was about as close as I ever want to cut it. We had maybe 10 feet to spare. From our position, I could see the results of the successful salvage operation. The Pelican Bay, which had been drifting uncontrolled for 18 hours, was now following obediently behind the Sea Guardian as Captain Mitchell began the long process of maneuvering the unwieldy combination away from the shipping channel. "The aftermath, Coast Guard, this is salvage tug Sea Guardian," Captain Mitchell reported. "The navigation hazard has been secured. Barge Pelican Bay is now under controlled tow. We're moving her to safe water clear of all shipping lanes." The response from Coast Guard New Orleans was immediate. "Roger, Sea Guardian. Excellent work. All vessels, the navigation hazard in the Gulf shipping channel has been secured. Normal traffic may resume with caution." Within an hour, the backed-up merchant vessels began moving again, resuming the flow of commerce that the drifting barge had interrupted. The Gulf Star and her followers proceeded to their destinations, and the economic impact of the emergency began to diminish. But the full cost of the incident was just becoming clear. With the immediate crisis resolved, attention turned to assessing what had gone wrong and what the incident would cost. The Gulf Ranger's failed towing block would require major repairs before she could return to service. The 18 hours of emergency response had involved Coast Guard vessels, salvage tugs, and dozens of personnel. Most significantly, the delay in delivering the drilling equipment to the platform would cost Chevron hundreds of thousands of dollars in lost production while the platform remained only partially operational. The preliminary estimate for the incident is $2.8 million, Gulf Marine Services insurance adjuster reported 2 days later. That includes salvage costs, equipment repairs, delayed delivery penalties, and Coast Guard response expenses. $2.8 million, all because a single piece of equipment designed and built to handle the loads it faced had failed in a way that no one had anticipated. The Coast Guard's investigation into the incident took 3 months and involved metallurgical analysis of the failed towing block, review of maintenance records, and interviews with everyone involved in the operation. Their final report would fundamentally change how the maritime industry viewed equipment reliability. The failure occurred due to a combination of factors that individually would not have caused problems, the lead investigator explained. Normal wear and tear had created stress concentrations in the towing block mounting. The wire rope wear, which seemed minor, was actually creating cyclical loading that the mounting couldn't handle indefinitely. When those factors combined with the normal loads of deep water towing, they exceeded the equipment's design limits. In other words, we had experienced what engineers call a black swan event, a failure mode that was theoretically possible but so unlikely that no one had planned for it. The Gulf Ranger incident became a case study in maritime engineering schools and insurance company training programs. Not because of any dramatic heroics or tragic losses, but because it demonstrated how quickly a routine operation could become an emergency when multiple small problems combined into a large one. This type of failure cascade is what keeps marine engineers awake at night, one industry expert commented. Individual components working within their design limits, but interacting in ways that create unexpected stresses. It's almost impossible to predict and very difficult to prevent. The incident led to new inspection protocols for towing equipment, revised maintenance schedules, and backup systems that hadn't existed before. The maritime industry, which had operated successfully with existing procedures for decades, was forced to confront the reality that good enough might not always be enough. But the most important lesson wasn't technical, it was human. When everything that could go wrong did go wrong, when equipment failed and conditions deteriorated, when millions of dollars and potentially lives were at stake, professional mariners had found ways to solve problems that textbooks said were unsolvable. 3 days after the salvage operation, the Gulf Ranger limped back to Morgan City under her own power, her damaged stern a reminder of how quickly the routine can become catastrophic. The Pelican Bay, now safely under the control of the Sea Guardian, had been delivered to the Chevron platform and her cargo successfully offloaded, though 18 hours behind schedule. As we tied up at the Gulf Marine Services dock, I could see the crowd that had gathered: company officials, insurance investigators, Coast Guard personnel, and maritime reporters who had heard about the incident. What should have been a routine return from a milk run tow had become a media event. "Captain Rivera," the first reporter called out as I stepped onto the dock. "Can you tell us what went wrong out there? How does a routine towing operation turn into a multi-million-dollar emergency?" The question would haunt me for months. How do you explain that sometimes, despite decades of experience, despite following every procedure, despite using equipment that had worked flawlessly for years, the ocean finds a way to remind you that nothing is ever truly routine? The formal debriefing took place in Gulf Marine Services conference room, with Captain Morrison presiding over a gathering that included Coast Guard investigators, insurance adjusters, and marine engineers. For 4 hours, we went through every detail of the incident, from the first signs of wire rope wear to the final successful salvage operation. "At what point did you realize this was more than a maintenance issue?" one of the investigators asked. "When the towing block mounting began to crack," I replied. "Up until that moment, everything was within normal parameters. Yes, we had accelerated wire wear, but that's happened before. The structural failure of the block mounting was completely unexpected." Bobby, James, and Maria each contributed their perspectives on the incident. Bobby described the engine's perfect performance throughout the crisis. James detailed the progressive failure of the towing equipment. Maria talked about the medical preparations we'd made in case someone was injured during the emergency operations. "What would you do differently if you faced the same situation again?" Captain Morrison asked. It was a fair question, but one with no easy answer. "Everything we did was based on the information we had at the time and followed established procedures," I said. "The equipment failure was unprecedented. The weather conditions were exactly as forecast. The crew performance was exceptional. Sometimes, despite doing everything right, you still face an emergency." While the financial impact of the incident was significant, the human cost was harder to quantify. For 18 hours, 4 people had dealt with the stress of watching millions of dollars worth of equipment drift toward disaster, knowing that our actions could determine whether the situation ended in successful salvage or catastrophic collision. James, in particular, struggled with what he saw as his failure to prevent the wire rope deterioration. "I should have caught it sooner," he told me during a quiet moment after the debriefing. "Maybe if I'd insisted on changing the wire when we first saw the wear." "You did everything by the book," I assured him. "The wire rope wear was accelerating faster than anyone had ever seen. The real problem was the towing block mounting, and that wasn't something any of us could have predicted." Bobby dealt with his own concerns about the engine's role in the incident. "Maybe if I'd been able to give you more power during the emergency, we could have reached port before the block failed completely." "The engines performed perfectly," I reminded him. "This wasn't a propulsion failure, it was an equipment failure that no amount of engine power could have prevented." The Gulf Ranger incident sent ripples through the entire Gulf Coast maritime industry. Insurance companies began requiring more frequent inspections of towing equipment. Marine engineering firms started designing backup systems for critical components. Training programs added new sections on cascade failures and emergency decision-making. "This incident changed how we think about equipment reliability," one marine engineer explained to a trade publication. "We've always known that individual components can fail, but we hadn't fully appreciated how multiple minor problems can interact to create major failures. It's forced us to design redundancy into systems that we previously considered bulletproof." Tugboat companies across the region began retrofitting their vessels with backup towing systems. Secondary winches, duplicate mounting points, and improved monitoring equipment that could detect developing problems before they became critical. For me, the incident was a watershed moment in 8 years of tugboat operations. I'd always prided myself on professional competence, on the ability to handle whatever situations the Gulf of Mexico presented. The knowledge that we'd come within hours of losing millions of dollars worth of equipment, and potentially causing a collision that could have killed people, was humbling in ways I hadn't expected. "You can't control everything," Captain Morrison told me during our private conversation a week after the incident. "Good captains understand the difference between the things they can control and the things they can't. Equipment fails, weather changes, and sometimes the ocean reminds you that you're just a guest out there." The words were meant to be reassuring, but they highlighted the fundamental uncertainty that defines maritime operations. Every time a tugboat leaves port, every time a line is rigged, every time equipment is put under load, there's a possibility, however small, that something unexpected will happen. 6 weeks later, after extensive repairs and modifications, the Gulf Ranger returned to service. The new towing block mounting was over-engineered compared to the original, with redundant attachment points and stress monitoring systems. Additional wire rope was carried aboard, and inspection protocols were revised to catch developing problems earlier. My first tow after the incident was a routine barge delivery to an offshore platform, the same type of job that had led to the emergency. As we cleared the harbor breakwater and headed into the Gulf, I found myself checking equipment more frequently, questioning assumptions that I'd taken for granted for years. "Everything looks good, Captain," James reported during his first deck inspection. The new monitoring equipment showed normal stress levels on all components, and the towing gear appeared to be functioning perfectly. But I couldn't shake the knowledge that 18 hours of emergency had started with equipment that looked just as good, during conditions that seemed just as routine. The Gulf Ranger incident became more than just another maritime emergency. It became a case study in how complex systems fail and how professionals respond when the unexpected happens. Maritime schools added it to their curricula. Insurance companies cited it in their risk assessments. Equipment manufacturers used it to improve their designs. But for those of us who lived through it, the lessons were more personal. We learned that competence and experience, while essential, aren't guarantees against failure. We learned that the ocean will always find ways to test human systems and human judgment. Most importantly, we learned that when everything goes wrong at once, the difference between disaster and successful resolution often comes down to the decisions made by people under pressure who refuse to give up. 7 years later, I still work tugboats in the Gulf of Mexico, though I've moved to a different company and different vessels. The Gulf Ranger was eventually sold to operators in South America, where she continues to work under different skies and different conditions. The incident taught me that there's no such thing as a routine operation when you're dealing with the ocean and complex mechanical systems. Every job, no matter how many times you've done it before, carries the potential for something unexpected. The key isn't preventing all possible failures, it's being prepared to respond professionally when they occur. I think about Captain Mitchell and her salvage crew, who risked their vessel and their lives to secure a drifting barge in conditions that made the operation extremely dangerous. I think about the merchant mariners who accepted delays and economic losses to avoid potentially catastrophic collisions. I think about my own crew who performed flawlessly under pressure when equipment failed and conditions deteriorated. The Gulf of Mexico continues to challenge mariners with its combination of heavy commercial traffic, powerful currents, and unpredictable weather. Every day, tugboats move barges, platforms, and equipment across waters that have claimed thousands of vessels over the centuries. Most of these operations are completed safely and routinely, testimony to the skill of professional mariners and the reliability of modern equipment. But occasionally, the ocean reminds everyone involved that maritime operations will always carry inherent risks. Equipment will fail, weather will change, and human judgment will be tested in ways that can't be fully anticipated. When those moments come, the difference between disaster and survival often comes down to the decisions made by people who understand that their job is to solve problems, not just follow procedures. People who know that when the routine becomes extraordinary, professionalism and determination can overcome failures that seem insurmountable. The Gulf Ranger incident reinforced a truth that every professional mariner learns eventually. The ocean doesn't care about your experience, your equipment, or your schedule. It will test you when you least expect it, in ways you haven't anticipated, with consequences that extend far beyond your immediate situation. But it also demonstrated that when maritime professionals face the unexpected, they find ways to solve problems that textbooks say are impossible. Not because they're heroes, but because they're professionals who understand that giving up isn't an option when lives, property, and the environment are at stake. That tugboat piloting was supposed to be safe compared to other maritime operations. For 7 years and hundreds of tows, that assessment seemed accurate. Then, 200 miles from shore in perfect weather conditions with experienced crew and well-maintained equipment, we learned that safe is always relative when you're dealing with the sea. The lesson isn't that tugboat operations are dangerous. It's that no maritime operation is ever truly routine. The ocean always reserves the right to remind you that respect, preparation, and professional competence are the only things standing between a successful voyage and a maritime emergency. The Pelican Bay continues to work in the Gulf, carrying cargo between platforms and ports under the control of various tugboats. The drilling equipment she carried during our incident was successfully installed and is now producing oil from the deep waters of the Gulf of Mexico. The shipping channel that she threatened has returned to its normal flow of commercial traffic. But for those of us who lived through those 4 days in March 2023, the experience serves as a permanent reminder that the difference between routine and extraordinary can be measured in the failure of a single piece of equipment, and that when that happens, everything depends on the decisions made by people who refuse to let the situation defeat them. They said tugboat piloting was safe, until the tow cable snapped 200 miles from shore. Then we learned that safety in maritime operations isn't about avoiding all possible failures. It's about being prepared to handle them professionally when they occur, and having the skills, equipment, and determination to turn potential disasters into lessons learned. The Gulf of Mexico is still there, still challenging mariners with its powerful currents, unpredictable weather, and endless commercial traffic. Tugboats still move barges across its waters every day, most of them completing their voyages without incident. But occasionally, the sea finds a way to test human systems and human courage in ways that remind everyone involved why maritime operations will always require the best that professional mariners can offer. This is the story of one such test, and the people who proved equal to it.